Hey everyone, welcome back to my channel. So in today's video, we'll talk about virtualization. We'll talk about what virtualization is. We'll talk about the benefits of virtualization. We'll see how virtualization actually works. And then we'll also talk about type 1 and type 2 hypervisors and what is the main difference between those. So let us first start by understanding what virtualization is. So virtualization in very simple terms is a technique that allows for multiplexing of a hardware resource, right? So the argument of virtualization is actually twofold argument. The first point is your cost benefit. So assume there is a hardware resources that is very costly, right? That maybe costs $5,000, right? Now, not everyone can buy that hardware resource, and not everyone, frankly, has the utilization or the need to buy that such a heavy resource, right? So, what the cost argument of virtualization says that if you are able to procure a hardware resource and you find a way to multiplex that resource into smaller chunks so that different users can use, then the cost of utilization per user will be very low, and therefore multiple people will be able to use, or multiple organizations will be able to use that resource, right? So that is why virtualization is important, because it allows you to multiplex a single resource into multiple different resources, and the cost of utilization goes down a lot. The second is argument of virtualization is utilization, right? So what utilization says is that someone may buy a very heavy machine, right? But they may not be using that machine to the most optimal capacity. Maybe they are just using 50% of the resources of that machine, and throughout the year they do not come across an instance where they are using it for maybe 99%, right? They are always at 50 and 60%. So that is not a very good use case. That is not a very good state to be in for every parties that are involved in the ecosystem. If there is a hardware resource that is lying underutilized, then it is a not a good situation for anyone involved. So what the utilization argument says is that if you have such resources, then you should find a way to multiplex this resource and share it amongst different users, so that one, your utilization goes up, and as you share these resources with different users, you can also charge them for this utilization, right? So the utilization of the resource goes up, as well as you can earn some money from that. And for the people who are using these virtualized resources, since you don't have to buy or procure those expensive hardware machines, your cost of utilization also is very reduced, because you are using just a chunk of that hardware resource. So this is the argument behind virtualization. Now, a very common counter to this that is proposed is that you already have processes running on a system, right? So processes is something that is a isolated entity. It runs in itself, and you can run n number of processes on a single hardware resource. So how is virtualization in terms of virtual machines is different from running processes on a same machine, right? So let us understand why that is different. So you have a let us take a example of a hardware resource, a CPU, and then you have different processes that are running on that CPU, right? Process 1, process 2, process 3, and these processes do have some sort of isolation also, right? So how strong this isolation is, we'll discuss in a moment, but they have some sort of an isolation, and theoretically you can run n number of processes until you exhaust your hardware resources. So it has your multiplexing capacity also. Now what happens is, for every operating system or for every machine, there are two modes of execution. One is your user mode, one is your kernel mode, right? Now a process that is running in a user mode is not allowed to execute instructions in the kernel mode. That is because these are privileged instructions and should not be executed directly by processes. So the kernel has to intervene in between whenever a privileged instruction is being used, and has to make sure that the instruction is correct and will not cause any harm to the system. So how does the kernel intervene? It intervenes by a method called a system call. So whenever a user tries to execute a privileged instruction, it generates a system call. It shifts the transfer of control from user to kernel mode, and then the kernel sees whether the instruction is valid and should it be executed or not. So one more thing we can discuss is what is a privileged instruction. So privileged instructions are a set of instructions that somehow have the ability to either read or modify the state of the hardware, right? For example, flushing of page table is a privileged instruction. No process should be allowed to flush the page table. So these are instructions that the kernel has to take itself, has to place itself in the in between of these instruction execution and make sure that these instructions are executing correctly. Now what happens here is that if there is a process that is running with an intention of harming the system or with the intention of causing some damage to the system, it can trigger or write some code that creates a kernel bug, that triggers a kernel bug. Now what will happen is, when as soon as the code executes which triggers a kernel bug, the kernel will crash, and as the kernel crashes, all the processes that are running on on the same CPU will crash, right? And the entire system will come to a halt. That is why the isolation property that we think is there in processes is not a very strong isolation property. Therefore, this does not hold. This is only suitable when you have some level of trust on the processes that are running on the system and you know that no one would intentionally try to hamper your execution. But when you talk about virtualization, you could potentially lend out, your users can be X number of any kind of people, right? You can have good users, you can have bad actors, you can have actors who are solely for the purpose of harming your system and all those things. So you have to come up with a construct that is immune to all such attacks, all such malicious intents, and still serves the purpose of sharing your resources amongst multiple different users, right? So let us see how virtualization works with the current setup, which is with the help of an hypervisor. So you have your hardware resources. So you have your hardware. Then on top of it, you have a VMM, right? A VMM or a hypervisor. So what is a VMM? VMM is a virtual machine monitor, or hypervisor is your HV is your hypervisor. So these are the same terms. There is no difference in hypervisor or VMM. It's just that some people call them VMM, some people call them hypervisors. And then on top of your hypervisor, you have your different virtual machines running. Now again, in this virtual machines, let us recreate the scenario that we were discussing. So you will have different processes that are running on these virtual machines. Now assume process 2 is a process that is running on VM3, has an intent of causing a harm to the system. It runs some code that triggers a kernel bug, but now since there is a separate OS that is running in VM3, the kernel bug will get triggered in the OS guest OS that is running on the VM3, and it will crash this OS. In turn, it will crash all the processes that are running on the VM, and eventually the entire VM will crash out, right? But the good thing here is that this impact of a crash is contained to a single virtual machine. It does not propagate outside the boundaries of where the process was running, and there is no harm to either your VM2 or VM1. And that is exactly what we want to do, right? Because in all practicality, there can be a case where VM1 belongs to company X, VM2 belongs to company Y, and VM3 belongs to company Z. So if there is a bad actor in company Z, there is no reason why a company X and a company Y virtual machine should crash, right? So that is why this is the first and the most important benefit of virtualization, which is strong isolation. The another benefit of virtualization that we get is run any operating system. So when you are talking about processes running on a CPU, you have a limitation that your process has to run on the operating system that your hardware supports or hardware is running on, or your kernel is basically running on or written in. But in virtual machines, you do not have that limitation. Hypervisor can support virtual machines that are running on different operating systems, even if it does not match with the operating system of the hypervisor or the host that on which the hypervisor is running on. So you are free to use Windows, you're free to use Linux, you're free to use Ubuntu. Any operating system you can use, you can run, and there is no limitations whatsoever on the operating system that the virtual machines should run on, right? You can use any. So this provides a very flexible approach, because obviously not all companies will use the same operating system. Every company has a different operating system depending on the use case that they are trying to solve. And then the final, and again a very important benefit that we get with this virtualization is portability. So now what is portability? So assume you have this setup. Now your hardware crashes out here, right? So your hardware basically crashes out because maybe a power failure, maybe a disk failure or something like that. That is beyond your control. Your hardware goes down, and this is not a very uncommon instance when you have thousands and thousands of servers in your server farm. One or two machines going down every now and then is a very common instance. What portability states is that given a new hardware system, which again has a hypervisor running on it, you should be very simply, seamlessly able to migrate this virtual machine onto a new hardware. Right? Now, how does this work? This only works because the idea of encapsulation has been so strictly imbibed and neatly imbibed in the design of virtualization that there is no tight coupling, there is no hard linking between the virtual machine that is running and the underlying hardware resources. Each and every interaction, 100% of the interactions have to go via the VMM, and then the VMM decides how it wants the virtual machine to interact with the hardware resources, right? So there is no hard coupling. Therefore, since VMM acts as a layer of abstraction between the communication between your VMs and the hardware resources, given a new hardware resource and the same hypervisor, same VMM, that level of abstraction is still maintained, and you can easily pick a virtual machine from one hardware and place it to a separate hardware, and this will perfectly work fine, right? So this is again a very, very important benefit of how virtualization has helped, because a server crashing is a very common instance, but if you are not able to recover your virtual machines from that crash, then that will be a very, very bad user experience. So therefore, these are the three benefits that we get from virtualization. One is strong isolation, flexibility to run operating system, and then portability. Now let us talk about how virtualization actually looks like, right? So let me now draw a more zoomed in view of these blocks. So first, so there are primarily 4 type of resources that can be virtualized. So let me draw those out. So the first resource that you can virtualize is your CPU. Then the second resource that you can virtualize is your memory. Third is your storage. And finally your network, NIC. So on top of this, so this is again your hardware. On top of this, we have discussed that VMM layer lies. And then you have your virtual machines here. So whenever you have a new virtual machine coming up, what will happen is that the hypervisor will carve out a piece of resources from all these physical resources and will map it to the appropriate VM. Now assume a new VM comes into picture. So VM2. So what will happen? A new section of the resources will be carved out and will be given to this virtual machine. Now how this happens, how the mapping is maintained, who decides this, so everything is in control of the hypervisor, because that is the only piece of software that is running on the top of these resources, right? It is a responsibility of the hypervisor to make sure that it allocates the resources judiciously and Theoretically, you can run n number of virtual machines on the system until and unless your hardware resources are all exhausted. So this is exactly how virtualization works, right? This is, now you can see how a single CPU resource you have carved out into multiple parts, and because most of the use cases you don't want that much of CPU, right? You need a very small, maybe a 2-core machine or a 4-core machine, right? You do not need a 500 core, 1000 core machine. So now you have the opportunity or the technical know-how to divide that 1000 core machine into multiple 2 cores machine and then give it out to different users so that they can use it for their own use case. Similarly, for other type of resources, that know-how is there, and that is what resides in your hypervisor, right? So that is how your virtualization works. Now let us talk about different types of virtualization. So this type of virtualization that we have been discussing is called a type 1 hypervisor or a bare metal hypervisor. It is called a bare metal hypervisor because VMM is in direct interaction with the hardware. There is no layer in between. So hypervisor is the direct entity that is in control of the hardware resources, and it sort of discusses, it sort of ensures that the resources are judiciously used and allocated to multiple different virtual machines that are running on top of it. So one example of type 1 is your VMware. Type 1 is actually the most common type of virtualization that we see. The next type 2 that we'll discuss, is not a very common or very prevalent sort of virtualization. So type 2 is actually very similar to this, but what you have is, for example, you again have your hardware, then instead of your hypervisor you have your host OS, and then you have your VMM, and then as you have already know that then you have your virtual machines, right? So now what happens is, so this is a type 2 hypervisor, also known as hosted hypervisor. So now what happens here is that every interaction that the VMM wants to do to allocate hardware has to now go to the host OS, and then the host OS goes to the hardware, does the appropriate things, and then responds back to the VMM. So this is actually slower than type 1, because obviously there is an extra hop that is now getting introduced. The latency of every interaction goes up, right? So this is not very commonly used, but there are still certain, I think, client-side virtualizations which actually use this. For example, VirtualBox is one example which uses type 2 hypervisors. So I think that is it. That is what I wanted to discuss about virtualization. So let us do a quick recap. So we talked about what virtualization is. We talked about the twofold argument for virtualization. One is reducing costs, and second is increasing utilization. Then we talked about why running different processes is not as same as running different virtual machines, because the isolation guarantee that we get while running processes is not a very strong isolation guarantee, and it can easily impact, a process can easily impact the execution of other processes. Then we talked about how virtualization is laid out. You have a hardware resource, you have a hypervisor running on top of it, and then you have different virtual machines that are running on top of that hypervisor. We talked about different benefits of hypervisor. We have strong isolation, we have the ability to run any operating system, and also we have the ability to port a virtual machine from one hardware to another hardware in case of a hardware failure. Then we talked about how virtualization actually works, how you can carve out small pieces of resources from a larger chunk of a hardware resource and allocate it to different virtual machines, and you can theoretically support n number of virtual machines until you exhaust the number of resources that you have. And then finally we talked about different type of hypervisors. That the first one is type 1 hypervisor, where there is no host operating system. Hypervisor is in the direct control of the hardware resources, and every interaction is just taken care by the hypervisor. Whereas in hypervisor type 2, there is an host operating layer that is existent in between the hypervisor and the hardware, and every interaction that the VMM does has to go through the host operating system before it reaches the hardware. So thank you so much for watching this video. I hope you found this content useful. If you want me to talk about anything in more detail, please write that in the comments and I'll try to come up with a video that talks about those topics in more detail. Please do not forget to like and share this video, and please subscribe to my channel. Thank you so much for watching.